We have about 50 to 70 or so active participants developing the standards. So it's a reasonable group for a standards committee. And we have over 200 companies that are represented from all different areas of process and industrial controls. So we've got chemical processing, so we got like Dow and DuPont and ExxonMobil, Petrochem. We got food and beverage, so we've got like Kraft and a couple others in there. We've got energy, so we've got like DOE as part of it. We've got some a few energy like T&D people. We've got some generator that are part of it. Pharma. We got like 3M. There's Bayer's involved. A few of those. Water. We've got like WSSC, which is the local DC like water companies involved. There's some other people as well, and we got some manufacturing. So like Ford, GM, and some other like discrete part manufacturing. Boeing is part of it. Things like that. So. And we've got both end users and we've got vendors. So the Siemens, the Emersons, the Rockwell Automations, some of the I/O vendors, things like that. We've also got them as well. So how does the standard series relate to ISA 99? So there's the committee, which is ISA 99, and that's a committee developing the majority of the standards in this series. And then there's the series number, and it's 62443, and that numbering comes from IEC. It's terrible, but that's what we're stuck with. So ISA 99 produces the ANSI ISA versions of the standard, the US national versions of the standard. IEC TC65 Working Group 10 develops the IEC version, and they're officially responsible for the IEC international versions. And then we're actually participating with ISO. The group's doing the 27000 series, which is all the IT security program stuff. We're actually working with them as well. So we're trying to really make this global and trying to work to really involve as big a group as we can to involve as much industrial automation stuff. Get the biggest portion of all the industrial stuff together and solve the majority of the stuff, and then have like each of the individual sectors or each application go and try and modify it slightly for their specific purpose. So I'll probably spend a lot of time on this slide just to give you an overview. It's an eye chart. This is available online, so I'll just give you sort of an idea of what's going on in here. No, oh well, not a big deal. So this top series up here is it's a bunch of standards and tech reports and things like that that relate to umbrella sort of over the whole thing. So the first thing we started out with in the committee was coming up with a baseline set of terms and concepts that we could actually all agree on. And when this all got started, there were people that couldn't agree on the word security. We couldn't agree whether we were dealing with physical security, cyber security, what levels that was integrated. Were we talking about, was the network part of this, or was it just the end devices? Was the network going to be controlled by IT? Was it controlled by the end user? Was it controlled by the vendor? So we had to come up with just a general set of terminology that talked about everything that we could all agree on. And actually that was the first document that we put out. So the one up in this top corner, 1-1, that's a terminology, models, and concepts. That document came out in 2007, and it's currently under revision to try and bring in a lot of the stuff that we've talked about and modified since that originally came out. The next document over is a master glossary. That was sort of a placeholder for us. We just sort of like, in coming up with this terminology, these were the terms that we agree on, but there was a master glossary of just like, here's all the terms that we've found out in industry and all their different versions of definitions, and all the references that we could think of, and we just sort of like piled them into a big database. And now every so often what we're going to try and do is sort of roll that current database off to an actual document that we can publish and say, this is the current set of definitions for everything under the sun that we can think of. Not the stuff that's specifically just used in our standard. This is everything. The next one over is a compliance metrics. It's trying to come up with some measure of how you measure security and the stuff that's specific to industrial automation systems. So it's not going to be it's not going to be a direct CMMI kind of like maturity model kind of thing. It's going to be taking in and trying to figure out how you actually measure security from an industrial point of view. And it's also not going to be down to the bits and bytes of okay, number of packet failures and stuff like that. It's going to try and come up with a sort of like higher level stuff that really makes sense to people and actually doesn't have to be boiled down much more. The other document in the series is a brand new document we're trying to come up with. We're trying to come up with a document that represents a large-scale use case. We're using a chemical truck loading facility as our use case, and trying to develop a life cycle idea that go along with that. So taking like the Microsoft security life cycle and trying to expand that out to include everything from initial project design through implementation, through FAT and SAT, all the way out to decommissioning of these systems in anywhere from 25 to 50 years. So that's all the umbrella stuff. It's stuff that covers sort of like the whole series, and then everything below this is sort of broken down into different areas that we're working with. So the second level down is all policy and procedure stuff. So this is in here. It's developing your security program in an end user facility. This is going and actually trying to take the 27000 series and the NIST SP 800 series and boil that all down to actually figure out what is special about doing security programs in an industrial organization. How do you have to go and modify that? What changes do you want to do? Things like not having 3 password lockouts on the nuclear power station's control center, HMI. Things like that. Stuff that generally is more policy and procedure related than tech related. So that it may relate to tech, and that's where the bottom layers come in. But generally, this is going to be the stuff that you go along with creating roles and responsibilities for an operator that's down on the plant floor, and he has different responsibilities than the engineer in his office trying to like write the programs to do stuff. And then he has different responsibilities than the sysadmin. And one of the things is the sysadmin shouldn't have ultimate superpowers. They should actually be locked down to where they can't do certain things, like change system process variables. Those should be dictated by the engineer. He may have the ability to do system OS level stuff, but he shouldn't actually be able to mess around with the user space stuff. Then the next document over, that's actually getting into a guidance document. So this document right here, the 2-1, that's a what needs to be included in a program. The next document over is a guidance document to say how you go about doing that. So there's a lot of issues of the control guys and a lot of the engineers and stuff like that are doing these programs in their real plants. They are not security guys. They are engineers. They know set points, they know chemical processes, they know how to build a network, but they don't know how to do a lot of the running of it. They don't know how to do the business level stuff of how you actually go about designing programs. They don't know a lot of that stuff. So we've tried to come up, and we've got the idea. Right now it's a light bulb because it's an idea. It's vaporware right now. We have not actually written it down, but really it's going to be how do you go about implementing this security program? Next document over is patch management. A lot of these systems you can't patch for 0 days. It just doesn't exist. A lot of these systems come down once a year for maintenance, if that. Some of them don't come down for 20 years because they work and they run and they're implemented and you don't touch them. The old engineering adage, if it works, don't break it. So don't try and fix it. And the next document over is actually, it's an attempt to try and create some sort of certification for vendors that an end user can actually verify that they're following their correct processes and they're designing a secure device. But it's more about, are they following their own processes, than it is about all the widgets and bits and bytes that they can bake into their system. So it's sort of kind of like an ISO 9000 or a 14000 for a vendor that an end user could come in and say, are you certified at this level or this level to build a product? If you've got somebody that's certified at a level 1, can they build a level 4 product that's supposed to be locked down completely? And there's issues like that right now. Then everything down below is all tech stuff. So this level, we're dealing with system level tech stuff. So this is going to be, when you build a system, you have to use a certificate authority, or you have to use some sort of cryptographic certification of devices and authentication. We don't specify what tech you got to use. We don't specify levels of tech. So we're not going to say you've got to use AES 256, because the minute we do that, 5 months down the road, 6 months down the road, that's old tech. So this is a standards point of view. By the way, one of these things you got to realize is that every single one of these standards has to actually be in place and unchanged for a minimum of 3 to 5 years from the IEC level. At 5 years, you're supposed to go and refresh it or re-vote on it, but it has to be in place for a minimum of 3 years. And think about how many of you replaced your PC in the last 3 years. Think about how many times Windows has come through updates in the last 3 years. So everything that we're talking about here is functional requirements, not actual interoperability and tech requirements, like down to bits and bytes level requirements. Someone would actually have to take this and say that at this point in time, this technology meets this functional need. So this level is all about system level stuff. So the first document in it's actually a tech report saying, okay, it's sort of like looking at the current state of technology and what general tech things meet some of the requirements in the standards. So a firewall. In all the other standards, we don't talk directly about firewalls. We talk about network segmentation. We talk about directional flows. We talk about restricting data flows, things like that. We don't talk about specific tech that meets those needs. This document actually gets into some of the tech and gives some guidance on how you try and configure some of that tech to meet these needs. But again, it's not going into device level stuff. It's saying this is a general type of device and it will meet most of these needs if it's configured properly. That's another problem.
So then it's vendor agnostic?
It's this is all vendor agnostic. We avoid vendor stuff at all possibility. Because it's IEC and ISO and ANSI, we've really tried to avoid any references to any tech. We do actually have a few in the document, but again, those are generally in like notes or sort of like general discussions of stuff. We mentioned Microsoft, of course, because there's no avoiding it, but we have avoided all like, we don't mention Cisco or Extreme or Hirschman switches or Rockwell PLCs or anything like that. We talk about general kind of stuff.
Is there any like suggestion between like proprietary and open source and stuff like that?
No, we've avoided all those discussions because generally that's it's a business decision in an organization to go with proprietary, open source, vendor specific, all that kind of stuff. By the way, yeah, if you want to ask questions, just speak up. I'm not in any, like, I don't, like, have to have 10 minutes at the very end to talk about stuff. So this is just sort of an application of current tech. The next one over, this is, actually, let me talk about this one first. This 3.3 document, that actually is, that's where we really get down into the technical requirements for system level stuff. And that's where we talk about adding a certificate authority. You've got this system that's a critical system has to work in what's called island mode, which is disconnected fully from the system, and it still has to be up and running. It gets into discussions of different levels of that. So we have what we call security levels 1 through 4. Just like the 800 series has the high, medium, and low for 853. We also have that in ours. We call them security levels 1 through 4, and I'll actually talk about that in a minute. But this gets into the actual requirements and any enhancements that go along with that. The requirement for having a password when it deals with resource availability stuff, a password is actually a detractor to availability. So for higher availability systems, we have recommendations to actually reduce some of the authentication and some of the access control requirements for higher availability, higher criticality systems. There's discussions of that kind of stuff in there as well. So what we did generally with this document, we started with 853, which is the NIST Special Publication 853. It has a huge number, I think it's like 214 or some large number of requirements in there, specific, and again, system level requirements. And we took a look at those to start with as our beginning place to start with, and then really worked from there. So we're up to, I think we've got in the range of 114, 120 kind of requirements in ours. And they all have been tailored for industrial systems. So this is taking them and all really looking at how you work for industrial systems and how you have to modify sort of the IT stuff to really work in industrial systems. And then this document in the middle, this 3.2, is sort of a glue that holds together the program with the system level requirements and the actual device level tech requirements. This is where we talk about how you actually take the requirements that are written in here. So your hazard analysis, your consequence analysis that's done up in this stage, and you translate that into security level requirements that are necessary to actually go into what the real requirements for your systems are, and how you design zones and conduits around things, and how you do your network segmentation and stuff like that to try and build a better system from the ground up. And then down here, we've actually got individual component level things. So this right here is actually taking the Microsoft software development lifecycle and trying to take the idea of it and think about what's necessary for producing stuff at the industrial level. And then this is security requirements for devices to meet these system level needs. It's not a one-to-one translation of what needs to be baked into a network switch to do some of the requirements up here at the system level. It's not really obvious sometimes what you need to bake into a logic controller or what you need to bake into software to meet some of the system level needs. So this is where we've tried to break it down into a device level thing, a set of security requirements to meet those system level needs.
So 4.1 is software and 4.2 is hardware and firmware?
4.1 is actually overall life cycle, so it includes hardware design too. Not going to the sketchy Chinese or backwoods gray market to buy your chips. Not going to not doing a good general hardware design and reliability analysis on your system and your device once you get it in place. Not doing those reliability checks. Not doing your due diligence when it comes to your overall architecture of your design, things like that.
Okay, so it's just overall.
It's overall. So it's taking the concept of the Microsoft software development lifecycle that exists and is actually well established, and Microsoft is sort of trying to use themselves, and taking that concept and those ideas and trying to roll it into an industrial market where you've got hardware, software, integration, and then all the other headings going on with that. Some other documents in the series that are actually in the works that don't show up in the official work products diagram. After Stuxnet came out, I know I'm not talking FUD here, so I'm not going to spread fear, uncertainty, and doubt. But after Stuxnet came out, basically there were questions of would 99 and the document series here to actually have been able to handle Stuxnet. And so we actually set up a task group to go through our standard. Generally, at the time, the only official standard that had anything going on was the security program document. So they went through that as their starting point and said, in the security program document, what were there gaps that would have allowed Stuxnet to propagate? Or were there stuff that, or the recommendations that we could use to actually fill and plug those holes? So they actually found 35 gaps in the standard. They identified them, and then they came up with actually 33 recommended improvements on those to try and, that we've now actually are in the process of trying to add into our revision to the security program document. So we're trying to roll in all, and these are, the guys that gave these recommendations are actually some of the researchers that actually did the research on Stuxnet originally. So we've got some of the world-class people that actually did some of the research to find what Stuxnet was, to do some of the decoding of it, to actually go and mess with the Siemens S7 systems and actually figure out what was really going on. And then another document that's been more recent in its adding in is it's a document. There was a report from the oil and gas industry called the Logic Consortium, and they actually went through and did a design, and they actually went into industrial plants and stuff like that, and actually looked at what are called safety instrumented systems, SIS, and they actually went and analyzed what kind of security architectures could be put in place, and they wrote a report, the Logic report. I think that's available online, and they gave that document to us to try and actually work with, and so we're trying to actually take that document, look at the oil and gas stuff, and then expand it out to be industry agnostic. So looking at their report, looking at their conclusions, and trying to actually go and generalize it out to be general industrial automations kind of ideas, and try and then once we get that done, once we get a tech report there done, then incorporating that material back into the standard series to see where we can really concentrate on safety and security, since that's a real big issue at this point. Some of the fundamental concepts that are sort of baked into the series. This is a real eye chart. Yeah, you won't be able to read this. It'll be in the slides, so you can read it there. This whole series, we really have seen these kind of like process kind of stuff. There's tech stuff, and then there's the people stuff. In terms of the process stuff, we've taken the 11 categories from the security program, the ISO 27000 series, and we've kind of put them along with this process, making sure you're doing your process correctly. Your tech stuff, so we've actually expanded on the CIA, confidential integrity and availability, to actually roll it out to 7 things that are really important for industrial systems. and I'll go into more of them in a minute. And then there's people stuff, so making sure your people actually understand the need for having a training program and the need for it's motivation versus defiance. So there's a lot of times where people will do everything in their possible bag of tricks to avoid getting IT involved or avoid getting the maintenance people involved. The guys, I worked in the manufacturing industry for quite a long, and the robotics guys, and they had handheld units that they would have to hold on to make sure that the robot would do its stuff. Otherwise, a big e-stop would come in, the robot would stop moving, and the operator had to basically restart the whole system. It was a safety thing. It was meant to actually keep people from being knocked over by the robot accidentally. But the problem is, all the guys figured out that if you wrapped duct tape around it or wrapped electrical tape around it, they didn't have to hold it anymore. Well, then the Robotics Industry Association came out and said, no, you actually have to hold it with a certain amount of force. So you couldn't just let go of it, and you couldn't grab it real tight. So but then people started developing carpal tunnel because they had to hold on to something and they couldn't just grab it real tight. So then they had to figure out all sorts of stuff like that, and the guys kind of figured out, well, if they wrapped the electrical tape, or if they shoved if they wedged some cardboard in there and then wrapped it with electrical tape, it worked for them. And people figure out ways around the system all the time.
Are you trying to create Terminators?
Yeah. But the idea of safety has really gotten baked into a lot of the industrial systems, especially the chemical plants. And so they actually have, a lot of times they'll have a sign up, so-and-so number of days since our last safety incident. And what we want to do is get to the point where safety and security are on the same board. So-and-so number of days between before or since our last security incident. We would love to see that. Don't think it'll happen, but we would love to see that kind of mentality towards security. And so there's other stuff that's sort of people solving the general overall people kind of things, relationships between IT and what's called IT and OT, information tech and operations technology. So there's those kind of things. So what we call foundational requirements, this is the easiest sort of stuff to start with when you're getting into our standard. This is actually where you get into the tech stuff, and this is taking CIA and expanding upon it to really fill out what's needed for industrial systems. So the top two really constitute what is normally called access control. When we actually started looking into the standard, and it was like there were 40 or 50 different requirements that baked into access control, and it just got to be too much to handle. So we decided to break it down into the identifying who this person is, and then assigning them to a role, but not actually saying anything about what the role is able to do, and then assigning roles and what responsibilities relate to those roles. So that's where we've got the identification and authentication. So here this person is, I'm Joe, and I am a system integrator. Okay, so that means I'm identified, and I got my little sign on me that says system integrator. Now, what is a system integrator allowed to do in DuPont's facility number such and such in this location? And that is assigned separately, and that's what we call use control. So this really gets into the authorization piece. This is the standard authorization. The next one down, a lot of times in the IT world, this is just data integrity. Now we're talking system integrity. So making sure the whole system does what it's supposed to do and does it when it's supposed to. So making sure that the PLC does its job, the safety system does its job, making sure that they don't receive bad information, but also making sure the overall system doesn't do things it's not supposed to do. Data confidentiality, that one's a direct translation from the IT world. But again, data confidentiality has a slightly different meaning. This is not just being able to do encryption on everything. This is, it involves some more things. restricting data flows. This is now getting into doing network design properly, getting into architecting your system so that these devices that really aren't designed to handle a lot of extra background traffic, a lot of extra extraneous kind of stuff on the network, they weren't designed with Ethernet and high-speed networks in mind. They were designed with dedicated 24-volt signals going back and forth, or they were designed with RS-232, at most 19.2 lines going back and forth. They were not designed to handle all this extra stuff. They were not designed to do encryption. There's some of the stuff that we deal with. They've got a 300 baud modem between two sides out to a water pumping facility, and you're not going to do large-scale block encryption on a 300 baud modem. So how do you do that kind of stuff? How do you do that network segmentation? How do you start looking at doing this breaking systems down and protecting, doing that network zone model kind of stuff in a real situation? Timely response to events. This is okay. Once you know that something did happen, what do you do with it? How do you actually make sure that the system, that bubbles up to a point where somebody can actually do something with it? How do you actually trip your IDS systems to know that something's going on? How do you actually teach the operators to notice when things seem a little wonky? Something's just not quite feeling right. These guys deal with these systems day in and day out. They know when something just doesn't feel right. Being able to say, from a policy level, being able to say that they're not going to get reprimanded because they stopped the manufacturing line because something didn't seem right with how the robot was working, or something didn't seem right how the miller was working, or the chemical, the burner system, or things like that. Something just didn't seem right. These guys know these systems. They work in the systems sometimes for 20 years, 30 years straight. They know them really well. They know, and being able to bubble that up. And then availability, this is more than strictly just system availability or device level availability. This is actually a system level availability, making sure that you can actually still run even if bits and pieces of your system start to fail. Making sure that the critical systems that absolutely have to run, no matter what, 24/7, 9/9 reliability, work when they absolutely have to.
Is that in relation to COOP, to their continuity of operations, or is it a separate entity outside?
Yes, it all depends. Some of it, it's like there are some systems that are regulatory, and some of the EPA regulations on some of the chemical plants and things like that. Those systems have to run no matter what, because if not, they receive like $1 million a day kind of fines and stuff like that. So making sure those kind of systems run regardless of what happens to the plant. Things like that. So I mentioned earlier about security levels. We've taken a sort of threat direction for our security levels. It's trying to defend against a casual or coincidental violation. So this is not leaving the recipe to Coke out on the desk where anyone walking by can see it. Not having the sticky note with the username and password for the HMI or for the PLC or for, well, there was a really famous picture of a submarine that had the fire control system and had the password on a sticky note that was right there on the screen. It's like, what were you thinking? And this was like, it was a publicity shot that they had come through and was published on the internet with the fire control system, passwords and username. So that's that kind of stuff. Solving the stupid human tricks. I mentioned it before. Stupid human tricks are level 1 generally. This is policy and procedure level stuff. There's some tech stuff in there, not putting unencrypted wireless on your system when you're trying to do control and things like that. So there's some little things that you can do at tech stuff at a level 1, but generally a lot of this is going to be policy and procedure level, solving stupid human tricks. The next level down is where you really get into some of the sort of like script kiddie level, the stuff that's out there. Since I've been doing reliability and performance testing for a while, one of the things we generally did is just download like the free version of Nessus and go and run that against devices. And you would be amazed at some of the things you find. Ping of Doom, which has been solved and patched and fixed for 15 or 20 years. That's still in systems. Because people bought their TCP stacks way back when and didn't bother to buy the source code so that they could fix it, or didn't bother to buy a site license or renew their licenses to fix stuff over the time. Just engineers, it works, they're not going to do anything with it, it gets the job done, so they're not going to fix it. Well, that's what happens, and so a lot of this level stuff is figuring out what we call simple means with low resources, generic skills, and low motivation. So this is not really dealing with someone trying to intentionally, well, this is intentional, but it's not going to be the it's not going to be the situation where somebody's actually trying to come through and do a dedicated hack on your system. This is an IT virus that just happens to get into your system because someone took the USB key from their PC on their desktop and brought it out to the HMI on the nuclear power facility. That kind of stuff. So generally, these are going to be sort of IT kind of like viruses or IT kind of situations that end up affecting you at the system level or at the industrial level. Down here in 3 and 4, these are intentional attacks, and they deal with people that actually have knowledge of your system to some degree. Maybe it's somebody that knows what a PLC is, knows what the Ethernet IP protocol or the Modbus protocol or Profinet protocol are. They actually have used these systems. Maybe they've played around. They know a little bit about how an industrial plant works. Maybe they know maybe they've got another guy that's working with them that actually is a chemical engineer that actually knows that you put chlorine in this place and you put sodium in this place and you put ethyl methyl death over here and you've got stuff going on.
So that's your insider element and your foreign actor.
Generally, yeah. This is where you've got to have some knowledge of the system. It may not be insider knowledge of your particular plant, or it could be. This could be the disgruntled employee that knows all the passwords, knows where all the bodies are buried, and things like that. And then that's here. This one is where you're dealing with generally someone that's extremely motivated to try and screw with your system. So this may be the state actor. Everyone talks about APT and stuff like that. This is that kind of situation. This is the Stuxnet level attack. Not that everything at level 4 will fix Stuxnet, but this is that kind of Dooku, Flame, Stuxnet, whether or not you believe it, the U.S. going against itself and things like that. This is this level of attack where you've got someone that's highly motivated to screw with you, and you're trying to defend against it. So this is a lot of times active, directed defense mechanisms that are working 24/7 regardless of what's going on. So I mentioned a couple times zoning and conduits. So this is trying to actually wrap your systems in well-known sort of like groupings. There is a relationship between network architecture, actual hardware network architecture, and zones. Zones are actually meant to be security requirement wrappers, but a lot of times it's easier to just start with that wrapper model and then work that down into actual like network architecture model. So a lot of times these actually relate directly to how a system is architected. So to get to this safety system from the internet, you got to go through the enterprise, go through the plant DMZ, go through the what's called the basic process control system, and then get down into the security, the safety system, and not just solving the tech stuff of doing that, but also having a higher level of policy and procedure level stuff for this level as well. So you don't take the USB key that you used up in the IT system to transfer files down into here. You have to go from a policy and procedure level. You've got to go through and actually From the enterprise level, you load it onto a server in the DMZ. Then the server on the DMZ is where you actually pull files from to get to here. You don't start loading things. These systems can't be touched in a lot of cases. So you've got to like work with the system and try and actually really work with the restrictions that are in place from a policy and procedure level, from a tech level, and design things properly in your systems. Another example is a manufacturing example. So this is, you've got robot cell 1, robot cell 2, and maybe there's, the part has to go from 1 to 2, but this guy doesn't talk directly to this guy. He goes through some sort of intermediate step so that the data can be sort of like washed and cleaned and make sure it's not doing anything it's not supposed to in the process. So that's my talk. Here's more information. We always encourage more people to join us and help out. You don't have to be industrial people. We have a large number of researchers involved in the work too. We're always interested in hearing different people's opinions. We have a wiki site. It's a SharePoint wiki, so if you hate SharePoint, just live with it. And we have a Twitter. It's used occasionally. It's probably less than once a week, but we post up meeting notices. We post up when we've got general information, things like that. Eric Cosman works for Dow Chemical. You can get either of us, our staff contact person, and please feel free to give us any suggestions. One of the things is on the wiki, we actually have posted draft copies of all the current versions of our standards. So if you want to read up what we've got and give us comments, feel free. Please do. We encourage the more people to give us comments than we can.
So the majority of this seems to be targeted towards the system owners to be able to help provide metrics and controls for their own existing systems and plans. Having been as an operational security person in the past, when you put out an RFP, you request that the vendors, when they come to the table, to have certain security controls and mechanisms. Is there any working group with like the Siemens and the rest of the manufacturers of these systems to include those features?
Yeah, absolutely. That's going to be down at these two levels. So as I said, this is actually 853 sort of modified and moved around to be system level industrial stuff. And so this has a lot of tech stuff in it and gets down into what you would need to include in a system. And this is the level of what we call the system integrator role. It may be an end user that has an engineering group inside it that does some system integration before they put things into into production. It may be a dedicated system integrator that ends up being like a first or second tier supplier to an end user, or it may be an end user that's trying to roll a bunch of stuff together to create a system, like a Siemens that goes and puts a firewall in front of their PLC or their DCS system and bundles it together and calls it a new product. But effectively, they're creating a system level thing and doing. So they have to take into account those kind of requirements. And then down at this level, yeah, it's dealing with what does Siemens have to bake into their product? What does Rockwell have to bake into their PLCs? What does the Cisco have to bake into their switches?
Yeah, from like auditing.
Exactly, all that kind of stuff. So this is where we're going to try and deal with all the people that come out and say, I found vulnerability such and such, and it's CVE this and that, and this is where we're trying to deal with all that kind of level stuff. So.
But you are working with like the manufacturers of these systems.
Yeah, out of that 200 plus companies, I would say there's probably a good 30 or 40 that are just vendors.
Okay.
And if you can name a vendor in the industrial space, we pretty much have them.
Cool.
So do you anticipate that vendors will get on board with this very much like they have with the federal government policies and start presenting over time products that are certifiable or in compliance with their standards?
Certifiable is a good word when you talk about the government.
Thank you.
I worked for
That's my
20
own
years
word.
in the government, so I understand that. But yes, I didn't mention it here. There is actually an ISA Security Compliance Institute that's trying to actually come up with a brand, ISA Secure, to go along with that. That's one group that's doing it. There's another group that's doing what's called the WIB, and that's a World Tech and those guys, and they've got another Achilles series of tests that they can certify things to the bronze, silver, and gold. There are people doing compliance and certification groups, but again, it's I didn't want to get into that. That's a different world, and there's actually some infighting that's going on, and it's a big pain. So you first.
Is this more of a recommendation set of documents, or is there certifications wrapped around a lot of this? And I can't really tell exactly which is where.
Okay, these are functional standards. Some other group would have to say you must work. But what we really are expecting is that end users would have to put these in their RFPs. That they would actually say, you must, if you want to provide work, if you want to work with us, you've got to be a PLC manufacturer that is security level 3 certified, and they go out and buy a product and they can put it in their RFPs. This is not.
Does that certification exist?
As I said, ISA Secure is trying to do it, and World Tech's trying to do it, and their group's trying to do it, but it's not there yet. So.
Question, for medical devices, there is a manufacturer disclosure statement for medical devices. Are you familiar with those?
I know of medical devices.
Yeah, and you have some, at least for control, that they it's not certified or certifiable. But you kind of provide some guidelines. I mean, how do you see that fitting in this framework?
We haven't had a lot of input from the medical device community. Only recently did they even start being considered industrial systems. So a lot of them still kind of have their blinders on and don't think they're industrial yet. But they're small, dedicated, individual boxes that have critical components to them, and they can easily be consumed by part of this work. We haven't really paid too much attention to them, but basically they could take from our catalog controls. The DHS has its catalog controls, the NIST has its catalog controls. We've tried to work with both of them. In fact, there's a mapping of how we relate to the NERC SIP, at least version 3, the SP800 Rev 3, and we've got some people as well involved in the DHS catalog controls. We've done some comparison to those things. We haven't messed around with all the other industries that are looking at stuff, just because we don't have anybody that's really involved in that group yet. We would love to hear about it and love to see somebody do that. We don't have enough people to really do that. Any other questions? Thank you very much.